أهلا وسهلا. السلام عليكم ورحمة الله وبركاته. جدا سعيدين بحضوركم اليوم لأول ورشة في الديتا ساينس تراك. معاكم ليلى شكران، طالبة إدارة أعمال، تخصصي نظم معلومات إدارية وممبر في ال DSC-IAU Core Team. بإذن الله ورشتنا اليوم هتكون جزئين. أول جزء هيكون Introduction to Data Science with Jonathan، وبعدين هيكون عندنا الجزء العملي اللي هنطبق فيه مع بعض على منصة Qwiklabs. So please welcome my very special guest, Jonathan Hart, who will kindly introduce you to data science, machine learning, as well as artificial intelligence. Thank you so much, Jonathan, for joining us in today's session.
Assalamu alaikum. Hello, everybody. I can't share my video, it seems, so you won't see my face just yet, but I'm really excited to be speaking to all of you today. I've never presented to anybody from Saudi Arabia before, but it's very exciting for me. I have a friend who recently moved to Riyadh because his mother is teaching at the Princess Noor University, which I believe is quite a large and popular university in your city. So yeah, I'm very excited to speak to all of you today. A bit about me. I'm a student at the University of Cape Town in South Africa, and my degree is business and statistics. So I do a lot of courses on things like finance and accounting and people management and also some computer science. But I'm very passionate about data science. I've taken part in hackathons, I've done online courses, I've done some internships. So I believe I'm quite qualified to speak to all of you today, but this is, I've only been doing these talks a few times, so it's a learning experience and we're all students here. So as much as I'm your instructor, I'm also your friend, and I do hope you enjoy what I cover now. So I'm going to share my screen and then we'll get started. Great. Allow me to open up the slideshow. So today we are going to start with my introduction to data science. We will then do an introduction to machine learning, and then I believe you'll be doing a lab hosted by Lila. We'll start by the question all of you are wondering, which is, what is data science? I'll give you a short answer, a long answer, and then what I call the helpful answer. Let me just get the pointer working. So the short answer is, data science is the science of analyzing data. This is a correct definition, but it's quite simplistic. It doesn't tell us how we analyze data. It doesn't tell us why analyzing data is important. The long answer is best summarized in this image. So this is quite overwhelming, but you can see that data intersects with all of these other tools and disciplines. We see things such as artificial intelligence, we see machine learning, we see business, we see statistics. It's very overwhelming and it doesn't tell us how it all fits together. So let's move on to my more helpful answer, which is, data science is the scientific process of transforming typically large amounts of data into information to guide decision-making. So this speaks to the core of what data science is. In today's world, there's a massive volume of data. Some of it is helpful and some of it isn't helpful. Some of it is structured, like business accounts or medical records or financial databases. But some of it is not structured, like social media posts, noisy stock price data, and all sorts of other data. So we need to take this very big amount of data and find out the patterns in it, and we need to use that data to make better decisions. And this requires a lot of expertise, and that's what data science is. So we go back to this image, it makes a lot more sense. We see all kinds of data, but only some of it is useful. And on the useful data, we need to apply all sorts of tools and techniques, such as machine learning, or deep learning, or predictive analytics, to extract information. And then we can use that information to help organizations or businesses or communities make better decisions. So there you go. It is a multidisciplinary field aimed at making data useful, and it requires business expertise, programming skill, knowledge of statistics, but most importantly, an open and analytical mind. You don't have to be good at all of these skills already. You just have to have the drive and the passion to make data useful, and then you'll pick up those skills along the way. So before I proceed, I'm just going to stop and check if there are any questions so far. Cool. No questions so far. The reason I'm just doing that is because I stop quite regularly and I'll answer any questions that have come up, just so that we can have more spaced out question sessions. So also, because these slides might go quite quickly, the slides will be shared with you afterwards, so you can always see later on. Okay, I see there's something in the chat. Everything is clear. Thank you so much. Great. So I've given you a bit of the why and a bit of the how, but let us dive deeper into the data science pipeline or the process. So I'll also use my internship experience to give you some real world examples a bit later. This is the data science process. We start by gathering the data. We then perform 3 types of analytics, and then we execute our decisions, and then we go back to the start. And I'm going to go into each of these sections in a bit more detail. So we start with what's called data gathering. And this involves working with the client and finding out the challenge that they want solved. Based on this, you'll request certain data from them, or you'll help them collect the data over time. And once you've done this, and it's usually quite a lot of data, you need to get it in the right format and clean it up. So you might want to, oh, sorry, I moved forward too fast. So yes, you want to get the data, you want to put it in a database, and you might want to clean it up. So this could be putting it into all sorts of organized databases. It could be removing missing values or removing useless information. The next step is the analytics process. And we break this down into 3 types of analytics. We have descriptive analytics, predictive analytics, and prescriptive analytics. So descriptive analytics is where you summarize and you visualize the data. This could be making all sorts of plots to explore the relationship between data features in the data, or to see how it changes time, or to see its shape. And this might indicate that some data is useless, or it might show you that some features can be combined into new features. And sometimes this is all that the client wants. They just want to see an analysis of their data because they don't have the skills to do that. But more often than not, we don't stop there. We then go on to the next steps of analytics, which I'll discuss now. But here we see some types of descriptive data. So we can maybe make a time series of our data and see that over time it's increasing. We can sometimes make a scatter plot with 2 variables, and we see here that there's some kind of correlation between them. We could do a histogram where we see how they compare to each other. And I mean, a bar plot where we can see which ones are greater than others. We could do a histogram and sometimes, overlay a distribution to see if there's a distribution that fits the data. And each of these descriptive plots tell us a story about our data. And then we want to present that story to the client. This leads us to the next step, which is predictive analytics. So more often than not, your client wants you to now make predictions off of the data. And predictive analytics is where a lot of the statistical learning techniques, such as machine learning, which we'll talk about, are used. And these are used to identify patterns or relationships in the data, and then to make predictions off of that. So this is, like I said, where tools like machine learning or statistical modeling come in handy. We could be trying to identify the different objects in an image. We could be trying to forecast things like sales into the future. We could be trying to fit a regression line to a bunch of information. We could be trying to take data and identify groups or clusters in it. So predictive analytics is useful for taking the data that we have gathered and using it to make predictions or to better understand relationships. Yeah. And this leads us to the last step, which is prescriptive analytics. And this is where we take all of these patterns and these predictions and we try to prescribe optimal decisions for the company. So if a company is predicted to have low sales, you might have discovered certain patterns or variables that will lead to higher sales if they change things. So you want to tell them that currently they're heading towards low sales, but if they change 1 or 2 things, it can go to high sales. So you'd have to understand what your predictions meant and interpret that and then report that to the client in a very nice format with lots of charts and lots of paragraphs just explaining the process, because a lot of them aren't as technical and expert as you are. So you need to make sure that they can also read and understand. And that leads to the last step, which is execution. And this is when we communicate the findings clearly to the client. We tell them what the next steps should be. So this is helping them execute, and it's also helping them execute those next steps, making sure that they follow through, because sometimes they don't have the equipment or the expertise to do what you told them to do. And you also need to monitor the process and get feedback and see how your predictions work into the future and whether you need to go back to square one and start again. So it's a very iterative process because whatever you discover in the execution stage will be used to improve the next step of data gathering, analytics, and execution. So now you know the data science pipeline, and I just want to talk very briefly about a company that I interned at called Data Profit. They're very cool, and they're also based in Cape Town, South Africa. And they've actually just gone international. In fact, they've just received about $6 million in investment. And they specialize in AI for manufacturing. So they help factories and foundries reduce defects and increase efficiency. And if you think about it, for a very large factory, just 1% more efficiency can result in millions and millions more in savings or profits. So it's very valuable to apply data science to these factories. If you haven't seen my face yet, but that's me over there, if you look at this photo. And the process I just showed you of data gathering, analytics, and execution is exactly what they would do with their clients. And now I'm going to try and make up a case study to try and show you how they would have done it. So we're going to go through a fictional case study. Now, we would start by obviously, getting the problem description from the client. So in this made-up scenario, we have a company called Supercars, and they're a car factory that sells two types of car A and car B. And in all these cars, they have to put a first aid kit in the boot or the back of the car. But the issue is if they deliver a car with no first aid kit, it has to be recalled. This means that the customer sends back the car, and the car has to have a first aid kit put in and sent back. And this could take a lot of time. It could be costly because you have to maybe give them a discount because they were unhappy with the service, all sorts of things. And Supercars tells us that they are recalling too many vehicles and they want you to help them out. Now, already they've tried to have somebody look at the cars and find if the cars are missing first aid kits, but even with employees looking out for that, they're still coming up with issues. They actually, 10% of their cars have to be recalled. So that's the problem they've given us. So we're going to start with the data science pipeline, which I just spoke about. We're going to start with data gathering. So this could be just gathering any appropriate data. Maybe we install a camera at the end of the assembly line and we take photos of all the car boots. And then maybe count how many times there's a missing first aid kit. So imagine that car A looks like this and car B looks like this. And then this is the first aid kit. And we can see that car B has a red boot and that car A has a black or blue boot. So we'll take this kind of information and we put it into a table. So our table could say the type, the ID of the car, and whether it was missing or not. We just want to get all this data in a nice, neat format, and then we can apply the analytics we spoke about. So we want to try and interpret that data by doing some analytics. So in this case, we've done a bar plot, and we find out that most of the time, the recalls are happening because of missing first aid kits in car B. In fact, out of every 10 times that there's a missing first aid kit, 9 of them comes from car B. And this kind of makes sense because if we look back at the photos, we see that the first aid kit is a dark red and car B is black and red. So sometimes the first aid kit could be blending into the car. And that's why the employees haven't been able to identify whether it's missing or not. So we could tell Supercars that that's the issue and leave it to them to sort out. Or, like I said, they might want us to fix it for them. So this is where we do the predictive analytics. And we might train a classification system that can, much better than humans, identify whether there's a missing kit in car A or car B. So we train it until it's better than the human employees would be. And this system will tell us, in this case, we can see a first aid kit, yes. In this case, there's no first aid kit, no. Here, there's no first aid kit, no. And here, there's a first aid kit, yes. So we train the system so that it's a lot more accurate than before. So when the humans are doing it, there were 10% error. Maybe with this system, there's 5% error. It's probably even possible to get 0% error if you train it well enough. So that's the whole predictive stage we were talking about. And finally, we would write a report prescribing a better set of behavior. So maybe we recommend a new system to them. We say, in this new system, the camera will take a photo of the boot before the car is sent out. Then you will use the algorithm that we trained to identify whether a kit is missing. And if it is missing, the system will warn employees and tell them to put a kit in before it goes out. So in this case, you see a photo of a boot with no first aid kit. The camera will take a photo, pass it through the algorithm, and it'll say to them, warning, there's no first aid kit. So that's the system that you recommend to the client. And then obviously there's execution. So this system might work very well for them, and you're going to monitor this, but in the future, the client might say, now we're adding a new car to our line, car C, and the system that you've built for them isn't working with the new car anymore. So that's why you would now start the process again, and you'd retrain the algorithm. So now this time it can identify missing first aid kits in car A, car B, or car C. So the process never stops. The data scientist's work is never done. At this stage, I'm going to stop and ask for some questions, if you have any. And maybe somebody can tell me what the 3 types of analytics are. Just a quick quiz before we move on. Would anybody like to try and say the 3 types of analytics? Okay, gathering data. So that's the first part in the pipeline, but it's not one of the types of analytics we spoke about. Okay, descriptive, that's good. Predictive and prescriptive, there you go. Great, thank you everybody. You've been listening, I'm glad. So we've talked a lot about machine learning, and how it's very useful. Yeah, we've talked a lot about data science, and we've talked about how machine learning, like in the case study, is very useful to data scientists. So because this is the focus of the lab, let's go deep into what machine learning is. I'm going to start with a quote, and I actually want you to tell me if you know who said this quote. So the quote is, "Machine learning is a field that is basically collecting lots and lots of data in order to create models and algorithms, and then data scientists can take those models and start applying them to all kinds of problems." Can anybody take a guess as to who said this quote? I'll look in the chat. Don't be shy. So we have a suggestion, the founder of Udacity, could be. Any other guesses? That's all right, okay. Oh, somebody says Bill Gates, that's another good guess. So it could be Bill Gates, it could be the founder of Udacity, it could be any human, but actually this definition was written by a machine. So I went to a website called Talk to Transformer, and I just typed in machine learning is, and I generated the rest. So you see there, it says machine learning is a field that is basically collecting lots and lots of. This wasn't taking a quote from the internet. This system actually wrote every single sentence here. It would write a word and then try and fit that into a sentence and then continue generating words. And you see it carries on. It starts talking about how it's a data scientist, and then it became a research assistant, and then it now finds itself in the middle. This was purely made by a machine, just kind of almost thinking to itself and writing that down. And that shows the power of machine learning. We can have a quote like this, and it looks quite credible and almost as if a human wrote it. Maybe it was Bill Gates or whatever, but actually it was just a machine. And this is quite scary because it makes us think, if we could be tricked by a machine, what happens if the news stories we're reading have been written by machines? What happens if the messages we get that we think are from our friends are from machines? So it's very exciting technology, but it's also quite scary. But let me give you a better definition of machine learning. So machine learning are algorithms that improve themselves over time through statistical learning methods. And that's the core of what machine learning is. It's not just an algorithm that seems smart. It actually can improve itself through stats. And these are some examples. We have linear regression, tree-based methods, neural networks, which is what we're going to be covering today in the lab, and then clustering and all sorts of other things. And there's a lot of confusion between artificial intelligence, machine learning, and deep learning. So let's talk a bit about that. Artificial intelligence describes any intelligent behavior coming from computers or machines. So when Siri or Google Assistant calls your parents when you tell it to, when you say, "Siri, please call my father," that is something that's quite intelligent. Or when the Google search result will find web results for you, or when robotic arms in factories make shoes, or when you have computer opponents in chess or video games. So not all of these algorithms are very advanced, and they never really, a lot of them don't ever learn or improve based on the new information they've received. So artificial intelligence can describe any algorithm that we think is intelligent or that does things that usually humans would do. But machine learning is one part of artificial intelligence. This is where, like I said, algorithms that get better over time, and they're good for making predictions or for identifying objects and images or for translation. So they're often good for tasks where we can't understand complex patterns as well as the machine might. So we use the machine instead of trying to do it ourselves, just like identifying medical kits in a car boot. So it's just one part of artificial intelligence. And just like machine learning is one part of artificial intelligence, deep learning is one part of machine learning. So deep learning is a complex type of machine learning with many layers. That's what we call them. So I've mentioned here that linear regression is a type of machine learning, but linear regression isn't a deep learning. Tree-based methods are machine learning, but they're not deep learning. Neural networks might be deep learning depending on how many layers they have. So there are artificial neural networks that aren't deep learning, and there are that are deep learning. And in the lab you do later, you will actually be implementing a deep neural network, which is quite exciting. Now we're going to do something fun. It's just a fun game where the algorithm will predict what I'm drawing because it has learned to identify the objects from thousands of other players who have played the game. So I'm going to briefly leave the slides and show you this really cool game. So it's going to give me images to try and draw, and it's going to try and predict what I'm drawing. But please forgive me if my drawing is bad. I'm not a professional. So it wants me to draw an ant. Let's see if I draw an ant in under 20 seconds.
I see pond, or shoe, or birthday cake, or ring. I see snowman. I have no clue what you're drawing. I see sink, or alarm clock, or bicycle, or motorbike. I see castle, or crab, or snowflake. Oh, I know, it's ant.
There we go. So at the exact last second, just able to guess it was an ant. Maybe it'll guess potato faster.
I see circle, or donut, or pond. I see cookie, or moon. I'm stumped. I see bear, or remote control, or face, or cow. I see traffic light, or eye, or pizza.
You see how it keeps guessing.
Sorry, I couldn't guess it.
What I'm trying to do, but it gives all sorts of suggestions, but it can't yet identify what I'm drawing, but it's trying its best. I don't actually know how to draw a hedgehog. Maybe we can...
I see rainbow, or line, or eyeglasses, or dumbbell. I see mouse, or belt, or mosquito, or rabbit, or eye. I see scissors, or bee. Not sure what that is. Sorry, I couldn't guess it.
Unfortunately, I'm not great at drawing. It's trying its best.
I see square. I see radio, or eyeglasses, or shovel, or house plant. I see cupcake, or yoga. Oh, I know, it's bulldozer.
There we go, recommended the bulldozer. Let's try a blackberry.
I see squiggle, or shoe, or glove. I see bottle cap, or bear, or cow, or necklace. Oh, I know, it's blackberry.
There we go. Last one, elephant.
I see circle, or bun, or pond, or flying saucer, or sleeping bag. I see mouse, or brain, or basketball, or ant. I see bee, or planet, or sea turtle, or angel. I see popsicle, or monkey. I see bed, or frog. Sorry, I couldn't guess it.
So you see it guessed some of what I drew, 3 out of the 6. And it's probably my fault that a lot of them were quite badly drawn. So it tried to kind of guess what I was drawing at, maybe mosquito, maybe rabbit, maybe bee. And these are what other people drew, which it did classify as a hedgehog. So it's quite a clever game. It's obviously not perfect, but it also depends on the quality of the drawer. So there are quite a few things in the chat. I'm just going to check what people are saying. Ah, yes, there's the thing. Some people tried to help me by saying draw some dots. I'm sure you would have all done a lot better if you had been doing it than I would. Yeah, so back to the slides. That was Quick Draw, which is quite a cool game. And at this stage, I want to talk about something called rules-based versus machine learning approaches. So in a rules-based approach, you can, through a bunch of conditional statements, maybe if, else, and, or, you can get the system to work just with a few rules. And that works in many cases. For example, if I want to send a message to a friend on social media, you can design that algorithm with a bunch of rules. You can design it as wait until I press send, then look for the person I'm sending it to, then send it to that person, and then mark whether they've received it or not. So many types of problems you can just approach with rules. But now we must think, in QuickDraw, could we have done that with a bunch of rules? So this is what people have drawn for Apple and QuickDraw. And you can see that there are thousands of ways you can draw an apple. Now imagine trying to describe an apple with a bunch of rules. You could maybe say it needs to have a certain height, or it needs to have a certain curve to it, or maybe it needs to have a stalk. But all of these apples look different. Some of them aren't very circular. Some of them aren't even completely drawn. Some of them have stalks, but even the stalks are different shapes. So if you tried to, with just a bunch of rules, describe an apple, it'll take you millions and millions and millions of years to identify all the different combinations. And even then, you still might not get it right. Whereas with machine learning, what QuickDraw does, it can identify very, very different types of apples because it learns the essential features. So yeah, how could we write rules to classify all of these shapes as apples? It's nearly impossible. But with a classification algorithm, we can do that. So QuickDraw does the machine learning approach. All of these carrots are drawn differently, but it can classify them all as carrots because it finds maybe the essential features. It finds that there's maybe a spade-like body. It finds that there's a tuft of leaves at the end of it. Sometimes it has wrinkles on it. So it picks up these features, and it can sometimes even pick up features we haven't yet described. And that's what makes it better than a rules-based approach. So there are examples where a rules-based approach are useful, and there are examples where a machine learning approach is useful. And what we're going to do now is we're going to do a bit of a quiz. So I'm going to ask you which approach is the best for the given problem, and you can say in the chat. So for alphabetizing a list of song titles, what is better, rules-based or machine learning? So I'm getting some people saying ML, and one person so far said rules-based. 2 people so far have said rules-based. 3 people so far, but mainly ML. So for this question, actually, rules-based is the correct answer, because you don't need a very complex algorithm to alphabetize song titles. You might just say, if you have 2 songs, take the first letter, and if the first letter comes before the other letter, put that one first. For example, if one song is song A and one song is song B, you can just say, put song A before song B because A comes before B in the alphabet. You don't need rules-based. You don't need machine learning for that. Or maybe 2 songs start with the same letter, so you have song AA and song AB, but then you just say, okay, then look at the second letter and see which one comes first. So with a simple set of rules, you can actually alphabetize. You don't need to learn over time. Now let's try another one. Ranking web search results. What's best here? Machine learning or rules-based? All right, so here, and I'm really liking the engagement from everybody. Here, everyone is saying machine learning, but Lila says both. And actually, both is correct. This is because most search engines use a combination of them. So Google, if you Google Riyadh, for example, so Google will firstly, just by a set of rules, it'll eliminate all the possible results that don't include Riyadh. So it will eliminate Cape Town, for example. It will eliminate America or Japan or China. So it can follow rules just to get to the kind of area it needs to look for. But then it uses machine learning to personalize a bit. So if I were to search Riyadh versus one of you, because you live in Saudi Arabia, it will maybe give you different results. It might give you restaurants nearby. Whereas for me, as a tourist, it might give me hotels. And this is because it's learned where I am and what country I'm from because of machine learning. So it is a combination. They use the rules to maybe get the results, but then to rank them, it maybe uses machine learning to find out which one's more relevant to you as the individual user. That's why if two people do the same Google search results, they'll get similar results, but not exactly the same. How about this one? Predicting housing prices based on location. Rules-based or machine learning? Nice. So almost everyone said machine learning, and we have two people that said rules-based, or a few. And the answer for this one is actually machine learning. This is because housing prices differ no matter where you are in the world. In some cities, it might matter if it's higher or lower. It might matter how many rooms. In other cities, it might matter on the view, or it might matter on the proximity to a university or to businesses or to places where people work. So it would be almost impossible to learn all the different kind of what are the important features in all the different cities and places in the world, whereas machine learning can learn that a lot better than we can. So machine learning works here. Here's another one, processing online payments, rules-based or machine learning? So here we're getting some mixed results. We're getting a bit of machine learning, a bit of rules-based, some people saying both. But let's think about this. So the answer for this one is actually rules-based. Because think about how processing online payments works. You say, I want to buy a shoe, and then the website will maybe check with the bank. So they'll check, is this a legitimate bank account? They'll check, does this person have enough in their balance to pay for the shoe? And if so, then process the payment, send them the shoe, give them a receipt. So as I've just said, with a few rules, you can lay out the system. You don't need to learn anything to process online payments. We can just program that ourselves. And here's one more, and I'm hoping that all of you will get this one correct. Classifying an object in a photo, rules-based or machine learning? There we go. Okay, so everybody has said machine learning, and that's correct. Just like we saw in Quick Draw, it would be almost impossible to define an object with a set of rules, whereas machine learning can learn the patterns. So if you wanted to describe a dog, there's so many different types of dogs. Some of them have longer ears, some of them have shorter ears, some of them are shaggier and furrier. So trying to get one set of rules that works for all dogs is impossible, but a machine learning algorithm can learn the essential features. Now, somebody asked me to explain again what rules-based is. So a rules-based algorithm is one where we can get it to do what it needs to do with just a few conditions. So like I said, with the banking app, it can be told that if somebody's balance is zero, they cannot make any payments. This is a rule that never needs to change. So a rules-based approach is suitable because we know what to do with certainty. But like I said, if you try to make a bunch of rules to teach an algorithm to identify an object like an apple, it will take a long time to try and get a good idea of what an apple is, and you could still make mistakes. So apples vary, but the rules for banking don't. So banking you can do with rules-based, but identifying apples or other objects, machine learning is better. Great. So here's a recap of what I've said. In a rules-based approach, the rules are defined, and improvements will come from just better algorithms. So when I gave you the alphabetizing algorithm, it might have been quite a bad one. There are lots and lots of experts online who've thought of really smart ways of alphabetizing and sorting data. So the improvements come from better algorithms. But machine learning is about learning patterns in the data, and the improvements come from additional data. So if we try to train a classifier to identify cats or dogs off of 3 examples, it won't be as good as if we use 1,000 examples, because with 1,000 examples, it can learn better patterns. And each has their benefits. You don't need to use machine learning for processing payments, and you don't need to use rules for identifying objects. So you need to know when it's appropriate to use the different things. And Google actually uses machine learning all the time. So here you can see a lot of its services, and you can see how they use machine learning for these different services. So like Gmail, like we said, Gmail is mainly rules-based because it's got rules such as check inbox, if inbox is full, tell the person that they're on our storage, or whatever. But it's also got some machine learning, such as the smart reply, where sometimes it fills in your emails for you and recommends things. So that's machine learning, but it's also rules-based. YouTube is also, rules-based in the sense that If you click on a video, the algorithm says load the video. That's rule. But then the recommendations and the fact that it learns your preferences over time, that's machine learning. So Google has a lot of different services, and all of the machine learning in some way. Now, it's easy to look at examples of machine learning and think it's this very magical system, because it does open a lot of new possibilities. But like I said, it's not a good fit for every situation. Sometimes rules are better. So we should now try and learn what are the problems that machine learning is best suited for. So the next section is going to try and clarify what machine learning is actually used for. So one of the big tasks of machine learning is classification, like we saw with quick draw. So classification systems will determine which class or which category an example belongs to. So it's often trying to label the same image. So a classification algorithm will learn how to tell that this is actually a lion and not a sheep or tiger. And in the lab that you'll be doing, you'll do a different type of classification system, and that's what we saw with quick draw. Regression systems. And regression systems output a number. For example, how long will it take to drive from point A to point B? It might output 3 minutes or 58.6 kilometers. So it might also predict something like the number of customers in a month. So whereas classification was looking at a limited number of options, lion, sheep, or tiger, regression can give any number in a certain range. Sometimes you want to learn how things are related to one another. So in this example, that will group that look like 7 and differentiate them from groups from things that look like 2. Or you might want to divide a certain plot into different regions and color code them. So in clustering, you want to maximize the differences between clusters, try and divide 7s and 2s, but you also want to minimize the difference within clusters. You might want to recommend a response. So often some of our services will recommend responses for us, or even Google, which will, Gmail, which will recommend how we complete an email, or maybe auto-fill in our words. That's another form of machine learning that's quite useful. And very, very similar to recommendation, we can also do sequence prediction. So here we see the system predicting the next keyboard that a user will select. Because if the word that you're trying to type is this, and you type in THI, it will learn from experience that most likely the next thing you're going to say is S, because you want to say this. And then another final one we'll talk about is called generation. And this is where you want to train it on one set of data and then apply that pattern to something new. So you might want to combine 2 images. So combine an image of a turtle with artwork to create a new one. Or you might want to transfer something from male to female or from English to Japanese. So that's another use of machine learning. So we're going to do some more quizzing here. I'm going to ask you what type of machine learning could be used for this problem. So recommending what someone will purchase based on previous purchases. What could this be of the options? So I see clustering, I see prediction, I see sequence prediction, all sorts. So the answer here is sequence prediction. So yeah, it's going to find out what the next thing in the sequence is. Let's say you purchased shoes, and then you purchased pants, and then you purchased shirts. It might realize, okay, you're trying to buy a full outfit, so the next thing might be a hat or necklace or something. How about this one? Labeling email as spam or not spam. So I'm seeing a bit of clustering, and I'm seeing a lot of classification. And yes, in this case, it's actually classification, because from the outset, we know that we want to either classify it as spam or not spam. We just want the system to kind of learn what the differences are. Just like the one with the lion, where we want to classify as either lion, sheep, or tiger. The reason it's not clustering is that clustering is often where we just want to find clusters in the data without knowing what those clusters are. So we just want to find as many partitions as possible to separate the data so that within a cluster, they're all the same, but between clusters, they're very different. That's the distinction. How about identifying trends amongst a group of people who have bought a new music release? So you want to group different music purchases into trends or into different groups. All right, I'm seeing a lot of clustering, and you are all absolutely correct. This is the perfect example of clustering because let me go back a few slides. So we saw with clustering that maybe you've got this kind of thing. You've mapped out all of the people on some form of graph. And you might find out that the people all here are similar, and the people all here are similar. Maybe the different features are, maybe it's the age of the user, and maybe it's the income of the user. Anyway, sorry, that's I went far back there, but yes, you're right, it's clustering for that one. Cool. The next one, predicting the strength of a password. What would be the best for predicting the strength of a password? Great, so everybody said regression, and actually for this one, it could be both. The reason I say that is because you might be classifying the strength as weak, medium, or strong, in which case classification is better because you just want to classify it as 3 labels. But you might be giving it a score from 0 to 100. So you might say that, that password has 99 out of 100 strength or 50 out of 100. So depending on whether you want to give it a score or you want to give it a label, a title is weak, strong, very strong, then it's classification or regression. So it could be both. And then I think this might be the last one. Estimating arrival time based on the time of day and the traffic. So maybe the length of an Uber trip or the time that you'll arrive when you're driving to the shops. So here everybody is saying sequence prediction, but oh, there we go. So somebody has said regression, and that's correct because remember, arrival time could be any number. It could be 1 minute, 10 minutes, 5 hours. So regression will take in all of the factors. It'll take in time of day, the weather, the traffic, all those kind of things, and it'll give you a number, the number of minutes or the number of hours or maybe just the time of day. But these things can be obviously difficult to distinguish. So most of you have given some good suggestions. And over time, especially if you do the labs and go through the slides again, hopefully it'll the distinctions will be made clearer. So there's a question of what's the difference between regression and sequence prediction. So regression, you would want to find a relationship between input factors such as time of day and traffic and the output factor, which is the arrival time. Whereas sequence prediction, you just want to find what's from history the most likely next move is. So let's say people wake up, they go to work, they go home, and they go to sleep. The sequence is kind of like that, where if you were told that the person woke up and went to work and they said, what's the next one? What's the next activity they'll do? Then through sequence prediction algorithm, you can work out, okay, they're going to go to sleep because you've maybe looked at the routines of thousands and thousands of people. So you can predict what the next step in their day is. And you might even predict the middle step. So they might say that I woke up, I went to bed, what did I do in the middle? And then maybe you kind of find out that they were working. So regression is when you want to just predict a number from a bunch of inputs that might or might not be related. And sequence prediction is when there's a clear step A, B, what is C? I hope that makes a bit more sense, but I can think of some more examples to maybe visually show you. Cool, so actually at this stage, I'd like to take in before we move on to explaining what's going to happen in the lab. Does anybody have any questions at this stage? Would you like me to re-explain any section? And remember, the slides will be made available. So if you can't remember what was rules-based and what was machine learning, or you can't remember what the different things were, then you can always go through the slides again, and you can always email me as well for more questions. And thank you so much for following so far and for answering the questions. Engagement in those activities, everyone is very good. Great, so I'm not going to be running a lab today, but I do want to give a bit of an overview of what's going to happen in the lab. I was checking the lab, there we go. So here's a question on what is the lab. So this is the link to the lab, and I think Lila will tell you how to get free access. But this is the overview of the lab that you'll see on the website. So I'm going to explain what each of these kind of terms are. But the idea of the lab is to create a classification algorithm using TensorFlow on the AI platform. I'm going to talk about what that is. So what are we building in this lab? You're building a classification model to predict income categories. So you've been given information on people, such as their age, their education level, how many hours a week they work, and you want to predict if they have less than $50,000 of income or greater than $50,000. So it's either 1 or 2. It's not a regression problem, it's a classification problem because we have a limited number of labels. If you were predicting the exact number, the exact income, like 47,000 or 63,000, that would be regression. But because it's just 2 labels, less than 50 or greater than 50, it's classification. So you're going to be building a neural network that will take in any type of input, which in this case is the data, which I'll discuss now, and you want to assign it to either less than 50 or greater than 50. And like we said, this could be anything. It could be in another scenario or 1. It could be lion, sheep, tiger. It could be red car, yellow car, blue car, or car A, car B, car C. Yeah, and this isn't the only technique we could have used. For these kind of problems, we could use logistic regression. We could use things called classification trees. We could use things called support vector machines. There are all sorts of different machine learning techniques to classify. And as a data scientist, you would learn the strengths and the weaknesses of each of these, and then you would learn to apply the most appropriate. So actually for this problem, a neural network might be too much. So we would often actually train multiple models. We would train a neural network, a logistic regression, a classification tree, and then we would compare them on different metrics. So we might say, we want to find one that is the best at predicting. So how many times is it correct? How many times is it incorrect? We might want to see which one is more interpretable, where we might want to say which one tells us more about the relationship between the data and the output. So depending on what you want to achieve, depending on constraints such as processing power, time, money, you will use one or many models and you'll choose the best one. In this case, this is the data we're working with. These are all of the inputs, and this is the output. So we've got things such as the age of the person, such the working class, which could be privately employed or unemployed, the education, which could be university degree or high school, the race, the hours of work per week, and a bunch of other ones. And from that, we want to predict their income as less than 50,000 or greater than 50,000. That is the classification thing we're working with. So given a bunch of what we call training data with labels like this, the model is going to learn by trial and error and get as many classifications correct as possible. But the model also wants to be open-minded so that if it sees new data, so a person that it's never seen before, it still wants to be able to classify them correctly. And like I said, we would try many different models to see which ones work best. Yeah, so the AI platform is a cloud platform, and I'm sure you all know what the cloud is. It's a system where we don't actually have to run a program or a task on our computer. It actually gets run on another computer somewhere else. And this is a cloud platform built especially for AI problems. So it can be used to train your models. It can be used to make your predictions. And it manages that data pipeline, which I was telling you about, that data scientists use. So you could store all of your data there. You could store all of your databases, like in our example of the cars. You could store your data about the car, the type, and whether it had a medical kit or not. It can do tasks such as labeling. So it could have you could have used that to train the algorithm, which would identify if it has a med kit or not. And the reason we want to use an AI platform is because some of these models could train for hours. Imagine how some images might be, to say, 10 megabytes big. And if you're training thousands of images and you're doing it on 5 different models, doing that on a laptop or doing that on an old computer could take a lot of time, could be very expensive, could take electricity, all sorts of things. So instead, you use the Google AI platform instead, because you can then get access to a GPU in the cloud, a very fast computer in the cloud that can do many things and sometimes can do it with multiple processes. And what you're going to be using in the lab is a kind of a library called TensorFlow. So this is a library used for a bunch of maths and machine learning related programming problems. It's actually owned by Google, and it's managed by the Google Brain team. So you just need to know how the pieces of the model fit together. You don't need to know all the maths behind it. So as a data scientist, if you know that I want to solve this problem with classification, you don't need to know how the classification algorithm works. You just need to know that I want to get my data and train a classification algorithm. I want to see the classifications made. I want to write a report and I want to give it to a client. So you can do the whole data science process, the whole analytics process, without actually understanding how these systems work behind the scenes, because something like TensorFlow does all of that heavy lifting for you. And then you don't need a good computer either, because you can use the AI platform. So things like TensorFlow and things like the AI platform make data science a lot easier. And yeah, so this is kind of where I'm going to stop, and I'll take a last round of questions. But before you go, I just want to give you some really helpful resources that help me get good at data science. So like I said, these slides will be shared with you. You can, in your own time, go and look at it. But Udemy is a great site with online courses, and my favorite course on it is called Deep Learning A to Z. And they will do all sorts of things. They will do classification algorithms, they'll do regression, they'll do sequence prediction. Everything we've talked about today, you can find on that course. It's a paid course, but it's often on discount. The team behind that course also have a very nice free site called Super Data Science. And they've got lots of free resources, and they've got learning paths there. So you can decide what type of data scientist you want to be. And they have a bunch of videos and a bunch of free and paid courses, which will help you down that path. They also have some free courses, such as the Artificial Neural Network for Regression course on Udemy. I think if you want to get into data science, it's important to be able to program, specifically in Python and R. Probably Python is more important, but both of them are very nice. So start with Python, and as I'm sure you know, there are many great tutorials, there are YouTube videos, there are free courses online. So programming in Python is quite important, but luckily you're very supported by lots of resources. It's nice to also have a bit of statistics knowledge. And there's a free textbook I can recommend for this. It's called An Introduction to Statistical Learning. And this one's really nice because for those of you who are more interested in understanding the maths and stats behind, let's say, the classification algorithm, which I couldn't go into detail on today, this is a very nice textbook. But at the end of the day, this is the journey I would recommend. Learn some basic Python using online sources, or maybe your degrees. Do the Deep Learning A to Z course in Udemy. Then maybe try and participate in some online challenges. So Kaggle and Zindi are two challenges where they have two sites where they have lots of challenges, they have lots of hackathons and competitions. And doing that will get you experience. It will show you how these things are actually very useful in the real world. And it will also help you get jobs, because to an employer, it's very impressive that you've, let's say, won a challenge online. It's a lot more impressive than saying that you have maybe just done a university course. And once you've done all of that, decide what type of data scientist you want to be and explore more learning paths in super data science. And at any stage, if you don't understand anything, look for a reference in this textbook, watch a YouTube video, contact me, and we can help you through it. And that's it from me. Thank you so much, and I'll take a last round of questions. So far the questions seem to mainly be about the lab. And yes, the slides will be shared, and I think that this talk is recorded. But yeah, we've got about 5 minutes until my time is up. So please, please ask more questions. If there's anything that I can explain again, I'll happily explain it. So here's that last slide. The slides will be shared, so you don't have to worry about not seeing it now. But if you want to take a quick photo and get started straight away, then these are great sources. So I'm actually not going to be doing the lab live with you. I think Lila or somebody else on the team will do it. I don't actually personally do courses, but I do these talks because I'm a data science enthusiast. But if you want to do a course online, I recommend Super Data Science. Very nice website, very nice resources. So somebody asked, my major is pharmacy. Will data analysis help me? I'm not entirely sure, but I do know that I guess chemistry is an important part of pharmacy. And I've been hearing a lot about how machine learning algorithms are helping with things like chemistry and things like biology. So let me give you an example. It's not a pharmacy example, but it's a kind of biology example. Imagine you want to identify if somebody has cancer in the brain. Now, people often take MRI scans, and if a specialist looks very closely at an MRI scan, they might say, that looks like a cancerous spot. This person could have cancer. But sometimes humans make mistakes. Often doctors make mistakes in identifying illnesses or prescribing medication. So you could train a system like a classification algorithm, which can look at the MRI and can identify cancerous areas a lot better than the humans could do. And there are actually quite a lot of nice articles and books that talk about how, give examples of where machine learning has done way better than humans have. So I definitely think that there's room for machine learning to be useful and disruptive in pharmaceuticals, in molecular biology and neuropsychology and all sorts of fields. It's very cool. It's not always just business. It's not always just, classifying income or predicting stock prices or whatever. You can use it for anything. It's really, really interesting and fun. I've got some more questions. I don't know whether a recorded video will be uploaded, but I'm sure the club will tell you after the session. And yes, thank you, everybody. Does AI come under data science? So I think Fai asked this question. I'm going to go back quickly in the slides to one of the earlier ones. When you get the slide, I've actually put all of my notes underneath each slide. So let's just look for it quickly. Here we go. So I've actually written down my notes over here. So you can read through that and it'll help explain everything I've said today. But machine learning is a type of artificial intelligence. It's what we call a subset. So everything that is machine learning is artificial intelligence, but not everything that is artificial intelligence is machine learning, if that makes sense to you. So when you get the slides, you can see for all of these slides, I've written my notes, and that will give you a better explanation, and you can take as much time as you want to understand that. Great. Well, thank you, everybody. I've got one more slide to show you. I just want to say to you all, it's been great. Good luck, enjoy the lab, and go and change the world, because data science and machine learning is helping a lot of people. It's good in the environmental sector, it's good in education, it's good in finance. So really, learn these things, learn how to use them, and then whatever you're passionate about, see if you can use data science, see if you can use machine learning to help people, to improve business systems, and to change the world. And I believe you can. Just work hard, be passionate, and good luck.
Thank you so much, Jonathan, for that entertaining presentation. It's fascinating how computers are learned to recognize objectives with high accuracy. أوكي، أتمنى أنكم استفدتوا وتعلمتوا أكثر عن الماشين ليرنينج والاي اي. and now it's the lab time. فبس حابة أعرف مين منكم حضر أول سيشن اللي كانت عن الجي سويتس. Okay, حلو. Okay, great. I think most of you have the monthly free subscription access للQwiklabs. بس in case إنه في أحد أول مرة يحضر معنا I will show you the steps. وبعدين بإذن الله يكون عندنا break 5 minutes so you have the time to تفعلوا حساباتكم. وبعدين we will back to start the lab إن شاء الله. Okay, بس خليني أوريكم أول شيء ال steps. Okay, so here are the steps. Here's the link. هحط لكم في الشات. اللاب مدته ساعة بس ممكن بإذن الله أخلصه أقل من ساعة. So I send you the code now. Okay. هنروح مع الستبس مع بعض. اوكي فخلينا نفتح اللينك. اوكي so اللي هشرحه دلوقتي للي مش معاهم الفري month subscription، اللي معاهم that's fine. اوكي خلاص. اوكي وصل. اوكي حلو ممتاز. So first of all اللي هنضغط هنا sign in للي عنده already جيميل account. اللي ما عنده جيميل account ممكن يضغط هنا join ويعمل له جيميل account ويبدأ يكمل الستبس. اوكي بس انا عندي جيميل account ف just I will click sign in. اوكي وبعدين sign in with Google. اوكي اوكي accept. اوكي وصلتوا معايا الخطوات ولا تحسوا مشيت بسرعة؟ ديما ادخلي من اللينك اللي ارسلته. اوكي برسل مرة تانية. ادخلي عليه وبعدين تسوي sign in. اوكي وبعدين هنضغط هنا enroll this quest. هيطلع هنا introduction to SQL, BigQuery and Cloud SQL. اوكي هنضغط start lab launch with 1 credit. المفروض we wait for 5 minutes until إن هو يتفعل monthly subscription. I hope you can see here إنه في هنا 5 credits. لما بعد 5 minutes لما يتفعل الحساب هيتحول هنا ل monthly subscription. اللي عنده أي مشكلة عادي يكتب لي يعني. Can you repeat please? Yeah sure. Okay. First of all ادخلوا على اللينك. حلو وبعدين سوي sign in إذا عندك جيميل account. إذا ما عندك جيميل account سوي لك جيميل account. حلو طيب وبعدين سوي accept terms and conditions وبعدين سوي enroll الكويست. هذه هي الستبس مرة تانية. أي مكان ديما. enroll quest. طيب ادخلي على اللينك مرة تانية. إذا عملتي already sign in ادخلي على اللينك مرة تانية. the request لما تفتح اللينك. اوكي بعد ما اسوي sign in. بعد ما تسوي sign in افتح اضغطي join الكويست او enroll الكويست. بعد enroll الكويست start اللاب وبعدين wait for 5 minutes بعدين end اللاب. اللي واجهتوا أي مشاكل عادي يتواصل معنا على حساباتنا على السوشيال ميديا على تويتر، وهنساعدكم بإذن الله. يا صح. أوكي هرسلك مرة تانية. هذه الستبس. أوكي فإحنا بس ننتظر بس 5 دقايق لما يخلص، عشان بعد كده يتحول هنا ال 5 credits تتحول ل monthly subscription. ساعتها يكون معانا 1 free month to use it in the Qwiklabs. It doesn't allow me to log in. ما أدري. طيب جربي مرة ثانية، وإذا ما ظبط معاكي تواصلي معانا على تويتر. الكويست اسمه Introduction to SQL for BigQuery and Cloud SQL. أوكي ناو عدت ال5 دقايق هعمل end lab. بعدين المفروض هنا بعد شوية بس هتتحول هنا ل monthly subscription. فخلينا ننتظر شوية بعدين نعمل refresh. Which video are you talking about? Yeah, I didn't see any videos. Okay, خلينا نجرب. Okay, حلو. So as you can see إنه أنا عملت refresh وتحولت هنا ل monthly subscription. I hope you all get it يعني. اوكي دخلت ولا لسه؟ اللي دخل يكتب. اللي ظهرت له monthly subscription. After 5 minutes just end the lab. دي هذه منصة الكويك لابس. فيها زي كورسز أو إحنا بنسميها لابس، تقدري تدخلي عليها وتتعلمي يعني تتعلمي تطبيق عملي وكده. It worked الحمد لله. اوكي كويس حلو. خلينا ناخد بس 5 دقايق بريك تكونوا كمان فعلتوا حساباتكم اللي لسه ما فعل، وبعدين نرجع بإذن الله. أول ما نرجع هنطبق مع بعض التطبيق العملي. هوريكم بالظبط اللاب ودي ما خليكي معانا يعني هتعرفي بالظبط الكويست واللاب وكل شيء. إذا ما تغير معاك شيء عادي يعني just click refresh البيج وهتتغير زي هنا. Okay, الحمد لله, congratulations you. روان جربي مرة ثانية, امشي على نفس الخطوات بالضبط, لأنه إحنا ما ضغطناش أصلا على اللاب أكسس كود. إذا دخلتي على الخطوات بالضبط, إنك أول شيء تدخلي على اللاب, أو سوري على اللينك اللي أرسلته في الشات, وبعدين تسجلي, اعملي ساين إن, وبعدين رون الكويست, بعدين start اللاب, wait 5 minutes, بعدين end اللاب. not introduction to AI. إذا قصدك على اللي في اللينك, لا, اللي في اللينك اللي هو sorry wait, اللي في اللينك اللي هو introduction to SQL. yes, launch with 1 credit, yes. أي صح ديما. لا تضغطوا على الكود اكسس لاب, لا اضغطوا على الكريدت launch with 1 credit. Okay, we're back. خلصتوا فعلتوا الأكواد؟ اوكي حلو. So هرسل لكم لينك الكويست. باقي دقيقة 2 minutes remaining. طيب I will wait for 1 minute. اوكي بس first of all يعني اللي خلاص اشتغل معاهم بس اضغطوا هنا enroll. بس لحظة خليني أعمل sign out. اوكي هذا هو الكويست اللي هنشتغل عليه. اسمه baseline data ML AI machine learning and artificial intelligence. The first step enrolled in this quest. Okay, don't forget this step. اوكي حلو. اوكي دخلنا على اول لاب بس لحظة عايزة اوريكم بقية اللابس. So هنا هم دول اللابس. هنا عندنا 6 labs. هنا it tells you ان هو level introductor ال 6 steps اللي هم ال 6 labs يعني و it usually takes 5 minutes و 10 credits. طبعا احنا we don't care about credits لأنه احنا عندنا monthly subscription. حلو. ال name of the course اوكي أرسلته في لينك اسمه baseline data machine learning and artificial intelligence. اوكي أهم شيء بس سووا في الأول enroll للكويست. اوكي حلو. هنا أول لاب بال AI اللي بنكون نشتغل عليه بإذن الله اليوم وبعدين ال data prep و data flow و data proc كل ده بإذن الله هنشرحه بعدين بس اليوم بس عندنا أول لاب. فهضغط على أول لاب. after 5 minutes click end lab وبعدين نعمل refresh so you can see إن هو here it's monthly subscription not credits. okay طيب so here as you can see هنا start lab. هنا الوقت بتاع اللاب. هنا زي الاوتلاين وهنا الاوفرفيو وهنا في سكور على كل ستيب هنعملها هناخد عليها سكور او تقدر تعمل فينش لللاب لما يكون 80% او 100% من البروسيس يعني. اوكي خلينا نبدأ start lab. use subscription. اوكي حلو. so هنا open Google Console. Google Console هو عبارة عن temporary account بيخلص وقته مع وقت اللاب هو اللي عشان نطبق عليه الخطوات. اوكي ف open Google. اوكي so use another account. هنا معلومات الاكونت. هنا اليوزر نيم والباسورد. اوكي ف just copy it and paste it here. اتمنى انكم معايا. إذا في أحد لسه عنده مشكلة أو شيء عادي يعني يقول. أوكي بعدها حطيت الباسورد. ديما أنتي وصلتي لأي ستيب؟ Can you repeat? Yeah sure. First of all ادخلوا على اللينك اللي أرسلته. أوكي أرسل لكم اللينك مرة ثانية. أوكي هذا هو اللاب أو الكويست بمعنى أصح. طيب راح يكون في شهادة الورشة. يس هندخل على اللينك هيفتح لنا اللاب أو الكويست. أوكي يفتح لنا الكويست. من الكويست اضغطوا على اللاب اللي هو AI platform وبعدين افتحوا start lab وبعدين open Google Console عشان نفتح temporary account. يس ابدأ اللاب وبعدين copy اليوزر نيم والباسورد لا، أحد يدخل اللاب بإيميله الشخصي. أوكي، ادخلوا هنا provided for you use subscription yes، بعدين confirm. أوكي، يمكن ما ظبطت معاك الخطوات، جرب مرة ثانية. أنت متأكد إنه في هنا monthly subscription ولا حسن؟ هنا المفروض يكون في monthly subscription عشان تقدر تضغط use subscription. yeah sure. لما نضغط هنا start lab هيفتح لنا هنا open Google Console. Google Console is a temporary account يخلص وقته مع وقت اللاب. اوكي، لما اضغط عليه هيفتح لي حساب. هنا معلومات الحساب already provided اللي هو اليوزر نيم والباسورد. اوكي، never use your personal email. ساعة وربع؟ لا، يبقى انت ما دخلتيش على الكويست المطلوب. الكويست اسمه baseline، بعدين ندخلي على الاي اي، هو ساعة بالظبط. طيب اوكي، هنا اول ما فتح لي الجوجل كلاود بلاتفورم. اوكي، هنا النيجاتيف sorry navigate. We will go to AI platform هنا، وبعدين notebook confirm. لا confirm. شوفوا هذا هو اللاب اللي احنا عملنا له in start lab. اوكي، هنا overview what we will build اللي جوناثان شرحه. هنا السيت اب اللي هي الجوجل كونسول اكونت. هنا launch ال AI platform اللي هي الخطوة اللي احنا فيها دلوقتي. بعدين احنا هنا اوكي، هنضغط هنا new instance، بعدين هنا TensorFlow 2.3 without GPU، بعدين confirm أو create. اوكي، عشان تضيعوا الستبس already existed، يعني هنا already خطوات اللاب موجودة كلها. ما عرفت دي، ما عرفت ايش. اوكي، خليني اعيد على السريع ما يطلع لي جوجل كونسول. ليه؟ اضغطي هنا start lab، هيفتح لك على طول هنا open Google Console. اول ما تضغطي عليها هيفتح لك صفحة لتسجيل الحساب، سجلي باليوزر نيم والباسورد اللي هم already هنا. اوكي، احنا هنا فتحنا الجوبتر usually takes from 2 to 3 minutes عشان يفتح. بس قولوا لي مين دخل، مين وصل معايا نفس الستيج هنا. اوكي حلو. اوكي great. ممتاز. اي لاب دخلتي؟ الاول لاب AI platform. yes new instance. الخطوات موجودة already في اللاب إذا حتى يعني هنا. أول خطوة إنك تروح للنافيجيشن، بعدين AI platform، بعدين notebook، وبعد notebook create new instance اللي هي هنا as you can see here، وبعدين TensorFlow، بعدين without GTD. خليني أرسل لك رابط الكويست على طول، سوري رابط اللاب على طول عشان تدخلي عليه مرة واحدة. يس شكرا وزين. هذا رابط اللاب. اوكي، على ما يفتح الجوبتر خليني اشرح لكم سريع المفروض نسويه. اوكي هنا هشرح لكم خطوات اللاب بشكل سريع يعني. first of all هيكون عندنا ال pre-process data. ال pre-process data where I input all the data needed. Okay, clean it and then organize it. يعني كأني بعمل prepare للداتا that I will use. حلو. وبعدين build a model architecture اللي هو ال infrastructure that I will be working on. بعدين عندنا ال training وال evaluating. في ال training and evaluating I will train the 80% of the data. okay, وبعدين I will test it. يعني زي كأني هدربها وبعدين هختبرها، بس لما هدربها على جزء بس من الداتا، وبعدين لما هختبرها على داتا جديدة يعني غير اللي أنا دربتها عليه. اوكي، نفس فكرة لما يكون عندك تيست وتدرس لتيست بعدين في الامتحان يجيلك تيست لا غير، يعني نفس الفكرة بالضبط، إنه إحنا you train in a data بس when you test it you test any new data. وبعدين اللي هي ال fourth step اللي deploy إنه إحنا to run it on the cloud and finally we will make the predictions. I hope النوت تكون فتح. اوكي great فتح. من join ولا sign in. If you have Gmail account, click sign in. If you don't, click join and just make a new one. Yes, إذا أنت لسه ما دخلتيش ال monthly subscription, yes, use your email. بس وأنت بتطبقي في اللاب never use your personal email. اوكي خلاص عادي كملي بيه. كملي باليور ايميل، بس انا اقصد وقت اللاب، يعني وقت التطبيق داخل اللاب لما تضغطي start lab never use your personal email. yes يكون من النت. اوكي حلو. وبعدين بعد ما فتحنا الجوبتر هنضغط هنا terminal. يا 3 دقايق usually takes more. حلو. طيب هنا الستيج اللي انا هحط فيها الكود is already here. هنا التيرمينال اللي احنا فتحناه وبعدين هنا الكود. اوكي I will copy it to paste it in here. بعدين enter. اوكي دي ما no problem، تواصلي معانا على التويتر واحنا هنساعدك. اوكي حلو. بعدين هنضغط هنا training data analysis، وبعدين self-based labs AI Qwiklabs. اوكي سو هنا الخطوات اللي هنبدأ نعمل فيها ال run للأكواد، كلها أكواد احنا بس we will just need to run it. ال steps هنا اوكي هنا already existed. اوكي خلينا نبدأ نعمل run للأكواد. أول كود اللي هو import اوكي run to get my data or to set up the cloud. اوكي حلو. بعدين run these all الكودز اللي خاصة بالسيت اب of جوجل كلاود. وبعدين run. اوكي حلو. هنا الداتا سواء هنا كان ال age ال education ال never married if they are married or not white husband wife and so on، يعني كل الداتا اللي خاصة اللي احنا we are training the model on. اوكي run on local. اوكي خلينا اوكي run. كلها أكواد that we just need to run it، بس في two steps بس اللي احنا هنعمل فيهم replace للكود، بس otherwise يعني you just need to run it. اوكي run ديما تواصلي معانا على تويتر، او ممكن تخليكي الاخر عادي يعني اشرح لك تاني، بس خلينا نخلص الرun الاكواد. Okay, as you can see here, it might take some time. أو which step do you mean؟ sorry. بعد ما أدخل على النوت بوكس، بعد ما تدخلي على النوت بوكس هنا اضغطي الجوبتر بعدين خليه يحمل. بعد خطوة نص الكود دوسي اضغطي انتر، وبعدين استني شوية هتلاقي انه الداتا هنا اتحملت او الفايلز هنا اتحملت، وبعدين follow these steps اللي هي هنا training data analysis اضغطي عليها، وبعدين هنا training data analysis self-paced labs AI quick start، وبعدين اضغطي على ال AI platform. Yeah, it might take more أصلا than 60 minutes. اوكي حلو، هنا الكود خلاص اشتغل. نكمل هنا ال import printer protections. As you can see here إنه إذا كانت في أي categories أو أي words اتحولت ل numbers يعني integers، زي ال education هنا كلها اتحولت أرقام، ال occupation اتحول أرقام. ده بيكون أسهل للموديل to train on، أسهل من إنها تكون categories أو كلمات، والأرقام كمان اتحولت للستاندرد مين أو اللي هو ال t-score. أوكي import. أوكي أوكي خلينا نكمل. ممكن تجربيه في وقت تاني يعني عادي، مش مشكلة إذا ما حملش معاكي دلوقتي. هو it usually takes time يعني أنا أول مرة شغلته يمكن أخذ مني 7 minutes or more than that. أوكي حلو، هنا الستيج that I need to replace. أوكي هنا شوفوا هنا your current GCB project name is that. أوكي هنا I will need to copy it. هما بس 2 steps that I need to copy or to replace، وبعدين هنا هنضغط paste. أوكي وبعدين run. أوكي خلينا نكمل. again. أوكي هنا في step 3 اللي هي run your training job in the cloud، في أول كود لما تضغط عليه run هيطلع لك هنا ال project name. just copy it and paste it in the هنا in the next code هنا، و don't forget ال dashes. Okay, clear? No, okay, so simply basically كل الأكواد you need to run it. Okay, until step 3 there's only you have to replace this code or this your lab ID to replace it in here. أنا كان مكتوب هنا عندي replace your project ID, I just copy and paste it here. Okay, نكمل run. اللي عنده سؤال يسأل أو اللي معلق في شيء عادي يسأل. اوكي هنا as you can see set the train data and evaluation data. هنا اللي بيقسم الداتا نصين عشان أول set يكون الترين وتاني set يكون evaluation، وبعدين يحسب نسبة accuracy. لما أدخل على الجوبتر فين أروح؟ follow these steps. training data analysis self-paced lab follow these steps. اوكي خلينا نكمل run. اوكي شوفوا هنا go back to lab instructions and check my yes هنزل اللايف بإذن الله and check your process. فهنرجع هنا لللاب. اوكي وهنضغط هنا check my progress to make sure that you completed the first step. yes ديما بإذن الله. اوكي طيب خلينا نكمل run. اوكي شوفوا هنا the second step that I need to replace يعني هما بس two things that I need to replace. first thing اللي هو كان your lab ID وهنا ال job ID. okay again copy and paste it in here. job ID لا sorry هنا your job ID paste. okay بعدين enter. okay نكمل. اوكي كويس. ممكن اوكي هرسلهولك في الاخر. هو in the last slide I'll show you بس خليني اخلص اللاب عشان الوقت. اوكي عادي ممكن يطول معاكم الستبس شوية على ما تحمل. اوكي so هنا check my progress. yes we completed. طيب now step 3.2 نرجع 3.4. اوكي في هنا 3 step 2 check my progress. اوكي لسه يمكن لسه ما اتحملت بالجوجل كلاود. اوكي run. اوكي and now go to lab to the extra. خلاص احنا كده خلصنا اللاب. خلينا نرجع check my progress. it usually takes time على ما يتحمل وبعدين يطلع لك إنه هنا check my progress. but it's okay if you are sure إن أنت you run all the codes then you have just to wait. if it didn't work يعني just try to repeat it again. يعني اعمل run الأكواد التانية مرة تانية وبعدين اعمل check. اوكي فيها step. اوكي خلينا نرجع نشيك إذا في شيء. البيانات اللي أعبيها من وين أخدها which بيانات do you mean؟ أي بيانات؟ إذا قصدك اللي في اللاب نفسه عادي بتطلع لك. لحظة I'll show you. هنا الجوب اي دي هنا وهنا أول واحد هنا أول واحد. أوكي هما بس two. أوكي ده أول واحد و the second one اللي هنا الجوب اي دي. أوكي أنسخها. اوكي الستep دي لسه بتحمل يمكن عشان كده مظبطتش معانا، بس anyway احنا كده تعتبر خلصنا اللاب. بس هنستنى لما تحمل بعدين نضغط هنا check my progress و test your understanding. خلينا نحلها مع بعض. A model version is an instance of a machine learning solution stored in AI platform model service. Can you guess? Can you guess if it's true or false? Yes, it's true. AI platform offers training jobs and batches production job. True or false? Yes, definitely yes. Okay. حلو. So احنا كده خلصنا اللاب. As you can see here, I still got 60 out of 100. I will be waiting for the process to complete to load هنا في الجوبتر، لأنه لسه دي لسه بتحمل ولسه تحمل. يعني احنا كده نعتبر خلصنا. إذا عندكم أي استفسار هنا social media platforms. If you want to contact us, have to create a virgin one. Just run the code. Just run the code. بس it takes some time، بس it will be good يعني. بإذن الله يوم الخميس. Where can I find the clear يعني هو run، هو نفس الرن. مش فيش أي حاجة تتعمل غير بس الرن، وبعدين بس في there's two things that you need to replace. بعد كده خلاص. أوكي بإذن الله يوم الخميس هنكمل مع بعض بقية اللابس عشان نكون خلصنا أول كويست في الداتا ساينس تراك. وطبعا حابة أفكركم إنه اللي هيخلص الداتا ساينس تراك في شهر سبتمبر. لحظة خليني أوريكم الداتا ساينس تراك هنا. هذا هو الداتا ساينس تراك. إحنا النهاردة بدأنا في أول لاب في البيز لاين. يوم الخميس بإذن الله هنكمل بقية اللابس وهنشرحهم. واللي هيخلص الفايف quests يعني in the شهر سبتمبر he will get a gift box from Google بإذن الله. Okay. If you have any questions, you're most welcome to ask. And not Python session. هيكون عندنا session نخلص فيها اللابس قبل Python. اللي عنده أي سؤال يسأل. احنا كده خلصنا. بس آخر حاجة نسيت أقولها لكم، لما تخلصوا كل اللاب just click end lab. Yes, شوفوا it worked for me. خلينا نشوف هنا check my progress. Okay, still loading. But once you finish it all, just click end lab and you will get a badge لما تخلصوا أول quest. لا هذا مش أول quest، هذا أول lab في أول quest. Okay, Twitter accounts. Here you go. طيب بس عشان تحضروا تحصلوا على شهادة الحضور you have to sign in في رابط التحضير. How to launch an AI platform notebook. Can you be okay? Yeah, sure. Okay. هنا أول ما تدخل okay هنا الجوجل كلاب بلاتفورم just go إلى ال AI platform بعدين notebooks. اوكي بعدين new instance TensorFlow بعدين اختار without GPU بس. Thank you too. Yeah, sure. أحد عنده أي استفسار أو أي سؤال أو اوكي فاين. شوفوا انا هنا كملت خلاص الستبس. it just take me some time. وبعد كده خلاص شوفوا انا تحولت السكور تحول لي 100 ساعتها I can press end lab. اوكي احنا كده خلصنا اول لاب في اول كويست في الداتا ساينس تراك. yeah sure احنا we are happy to help. كده شوفوا هنا طلع لي هنا انه انا خلاص I completed the first lab. باذن الله باقي اللابس هنكملها في يوم الخميس باذن الله. اغير الجوب اي دي. انتي مش هتغيري الجوب اي دي، انتي you will just copy and paste it, just replace it. يوم الخميس فيه بايثون واحنا قبل البايثون، احنا هنكون في نفس الوقت تقريبا من 5 ل 7 والبايثون هيكون بعدها في الجوب اي دي مكان الجوب اي دي في الكود اللي بعده. في اي سؤال؟ اوكي سو رجعنا ارسلت لكم الرابط. اعملوا جوين فيه عشان تقدروا تشوفوا الايفنتس بتاعتنا وتقدروا تسجلوا في الايفنتس اللي هتحصل يوم الخميس باذن الله. Thank you all. وين افتح ال AI platform Qwiklabs؟ الرابط وين؟ اي رابط؟ لا ده افتح اخر واحد اللي هو 2.3 TensorFlow. الستبس كلها existed يعني. لحظة خليني افتح لكم مرة تانية. هي بس كل فكرة انك بتدخل على النوت بوك you just need to run the code، بس هي دي اللي مش موجودة هنا في اللاب، بس otherwise it's all كل الستبس موجودة. أي صفحة I guess try one more time. Thank you all. I hope you enjoyed the session. إذا عندكم أي أسئلة أو أي استفسارات تقدروا تتواصلوا معنا على حساباتنا في التويتر في الانستغرام. بس thank you so much.